Welcome to the Explainer. Today we're diving into a paper that is literally changing how we think about AI collaboration, MetaGPT. Multi-agent AI systems have incredible potential, right? But honestly, they often just devolve into total chaos. So we're going to look at how researchers solve this by applying real-world human workflows to AI. It's like turning a messy group chat into a highly functioning software company. Let's get right into it.
Okay, here's our roadmap for today. We'll start with the multi-agent problem, then look at the MetaGP solution, the assembly line workflow, structured communication, some real-world software generation, and finally wrap up with the results and future impact.
Let's kick things off with Section 1, the multi-agent problem, when AI chats just a little too much.
So why do AI agents fail at teamwork? I mean, you'd think that if you chain a bunch of really smart, large language models together, you'd get brilliant solutions, right? Well, not exactly. Without structure, it's basically like locking a dozen brilliant experts in a room with zero agenda and no leader. What happens? They just talk over each other. Or worse, they get caught in this infinite loop of idle chatter and cascading hallucinations, where one AI's mistake just spirals into the next. Just look at the difference here. Traditional LLM chaining relies on unconstrained natural language, so you literally end up with AI agents doing weird role play, asking each other things like, "Hi, have you had lunch?" totally forgetting what they were supposed to be working on. MetaGPT fixes this. It enforces strict standardized operating procedures, or SOPs. This mandates structured outputs and assigns clear, unmistakable roles for every single agent. Nobody is asking about lunch anymore.
Moving on to Section 2, the MetaGPT solution, simulating a software company. To fix all that chaotic chatter, researchers actually looked to human organizations. Think about it. Humans use SOPs, standardized operating procedures, to break down massively complex tasks while keeping quality control in check at every step. MetaGPT takes this exact organizational playbook, something human companies have literally spent decades perfecting, and just hands it directly to the AI agents.
And that brings us to this really cool concept, metaprogramming. Basically, it means programming to program. Instead of writing one massive, complicated prompt, we are literally programming an AI framework to autonomously program software for us. It's an orchestrated group of highly specialized AI agents working together like a well-oiled machine. Which brings us to Section 3, the assembly line workflow, input, process, and output.
Check this out. It's like a digital assembly line. A simple one-line user requirement comes in and watch how it flows. It starts with the AI product manager, who hands it off to an architect, then to a project manager, an engineer, and finally a QA engineer. Every single agent has a distinct personality, a very specific goal, and strict constraints. It is quite literally a simulation of a human software development team.
The workflow is built on clear, standardized steps. First, the input, generating a product requirement document, or a PRD. Step 2 is translating that into a system design. Step 3 is the actual coding. That's your core process. And finally, the output, testing the code with executable feedback to make sure it actually runs. The cognitive load is perfectly distributed. No single agent is getting overwhelmed.
All right, Section 4, Structured Communication Explained. No more telephone game.
You know how direct one-to-one communication can turn into a giant, messy game of corporate telephone? Well, MetaGPT completely avoids that by using a publish-subscribe mechanism. Imagine a central bulletin board. Agents pin highly structured documents to the shared global message pool. Then, other agents subscribe to that board, but they only pull the specific data their role actually needs. The architect only cares about the product manager's document. They couldn't care less about what the QA engineer is doing. It completely eliminates information overload.
And here's how that communication protocol actually plays out. On the left, you can see agents extracting only their specific task data from the shared pool. But over on the right, this is where the magic really happens. The engineer agent doesn't just write code, it actually runs it. If it hits an error, it doesn't just blindly guess. It checks the error against the original design documents in its memory, self-corrects, and tries again. It's iterative programming with real executable feedback.
Okay, Section 5, real-world software generation, from theory to practice.
So, enough theory. What happens when we actually ask this system to build something, like a custom drawing app? Well, it starts right here. Based on a super simple human prompt, the AI product manager outputs this incredibly structured product requirement document. Notice how it's not just spitting out code right away.
It's outlining exact user stories, doing competitive analysis, and building a requirement pool. It sets the strict guardrails for everything that follows. Next up, the architect steps in. It takes that exact PRD and translates it into actual system design components. It's literally mapping out the precise classes and interface definitions that the coders are going to need later. It's building the blueprint before a single line of actual code is written, which ensures every agent stays perfectly aligned. And the results? They are completely tangible. What you're seeing are functioning mini-games, data visualization tools, and graphical interfaces that were entirely generated by the MetaGPT framework. End-to-end, fully executable applications, not just blocks of text.
Finally, Section 6, Results and Future Impact, shattering the benchmarks.
So how does this SOP-driven approach actually hold up against the competition? Let's put this data into plain English. When put head-to-head on software development tasks against ChatDev, another really popular multi-agent framework, MetaGPT absolutely crushes it. For executability, MetaGPT scores a near flawless 3.75 out of 4. It does it in significantly less time. And get this, it essentially uses half the tokens per line of code. Plus, look down at the bottom there. The human revision cost drops from 2.5 all the way down to under 1. And if we look at the really rigorous human eval coding benchmark, the results are just staggering. On its own, GPT-4 has a first-try success rate of 67%. Pretty good, right? But when you drop that exact same GPT-4 model into the structured MetaGPT workflow, its success rate shoots up to an incredible 85.9%. It turns out giving AI specialized roles and structure actually makes the underlying model dramatically smarter. But honestly, the craziest part? In their experimental evaluations of complex, real-world software tasks, MetaGPT achieved a 100% task completion rate. Every single complex task they threw at it, it finished. That right there proves just how incredibly robust it is to use human-like operating procedures to guide AI. This quote from the researchers perfectly sums up why this is such a big deal. We are moving way beyond the days of just typing a single prompt into a chat box. We're entering this wild new era of fully autonomous, specialized AI economies. Systems capable of tackling massive, multi-tiered engineering challenges that no single AI could ever dream of handling alone. As we look toward a future where AIs can essentially hire other specialized AIs to complete massive projects, I want to leave you with one final thought. If AI agents can successfully organize and simulate an entire software company today, what human organizations will they simulate tomorrow? Law firms? Hospitals? The architecture is already here. Thank you so much for joining me on this explainer, and keep exploring.